Good afternoon to Dr. Masdi, our Manufacturing Technology 2 lecturer. We are from Group 2 and today we will present analysis on processes and manufacturing system of flange production. This is the group mate for Group 2, HAREEN, PUTERI, AIMAN, ALIF and also AINA, KAMALIA. Introduction and problem statement. Flange is a method of connecting pipes, valves, pumps and other equipment to form a piping system. We will use ASTM A182, the grade F304L. Production requirements: 50,000 flanges per month. Objectives: to select the best material for the flange, to select, describe and analyze in detail the manufacturing process for the flange, to propose the manufacturing process flow to produce the flange including the inspection and quality control. Finally, to establish the number of equipment needed to produce the required flanges. Selection of material. We will look into two characteristics, which are mechanical and also chemical. Manufacturing processes. The first one is cutting, 5 seconds. Second, forging, 15 seconds. Third, vertical drilling, 20 seconds. Fourth, cross drilling, 15 seconds. And finally, heat treatment for 5 seconds.
A very good day to you, Dr. Masdi. My name is Puchina Diana and I'll be talking about the assumptions and the calculations in order to achieve the required 50,000 flanges per month. First, we assume that we have a 2 7-hour shift per day, 30 days per month. From there, we calculate the rate of production by estimating the cycle time for each process. As you can see here, we have a total of 6 manufacturing processes, each with a different estimated cycle time. To calculate the rate of production, we first have to find the time taken to make one batch, which is the setup time, plus total batch size times cycle time. Next, we find the time taken to make one part, which is TB, time taken to make one batch divided by the batch size. And lastly, the rate of production is found by inversing the time taken for each part. Hence, we have the number of equipment for each process, meaning we use one machine per operations, which is a total of 6 operations. After that, we calculate the plant capacity, which is the number of machines times the total number of shifts per hour times the total rate of production divided by the number of operations, which is 6, and therefore we get more than the required amount, which is 50,758.4 flanges per month. Quality control is the process that helps a manufacturing company ensures it creates a quality product and the staff and management makes minimal mistakes and product defects. That is why there are 5 factors that ensures us the safety and quality for every manufacturing product. And the factors are dimensional inspection, appearance issues, mechanical properties inspection, defect inspection, and lastly, leaking casting.
Hi, my name is ALIF. Today I'm going to explain about procedure for calculating the cost of flange manufacturing. First step is weight of the raw material. Second, cost of operation. Next is operational cost. They consist of 6 equipment. First, close die forging manually operate hydraulic press. Second is jig grinder, driller, 8 vertical drilling. The third, jig grinder, driller, 2 cross drilling. Fourth is control gasifier conveyor furnace. And fifth, heating furnace and seat inspection tool. The total cost is Rm 145,624 ringgit. Next is weight of the raw material cost. Total mass for 50,000 flange is about 89.7 ton. Cost for cylinder rod Rm 2,082.75 ringgit per ton. Cost for cylinder rod for 50,000 flange Rm 186,803 ringgit. Cost for cylinder rod for 1 flange Rm 3.74 ringgit. Cost of operation consists of 2. It is fixed cost and variable cost. For the fixed cost, consists of factory, building and operational costs. For the variable costs, include of worker cost, raw material cost, and utilities. The total cost per pieces RM 10.47 ringgit.
My name is HAREEN, and today I'll present to you about the FlexSim simulation of the project. So, in our model that we use in FlexSim software, it consists of 6 stages of manufacturing processes, and each of them consists of processors and also multi-processors, and the whole plant is operated by human operators. So when the product is flowed through the input, it goes through heating and cutting multi-processor first, and then after that forging and stamping occurs. And after the forging and stamping process, inspection for deformation is done. After inspection, 4 vertical drilling and also a cross drilling process is done. And then after the drilling occurs, we inspect for the hole, and we do a hole inspection before passing through the products through heat treatment. And after heat treatment is done, the final inspection is done and the flanges are ready to be shipped. And here is a video of our simulation that we've done. So next, we managed to obtain a few data from the dashboard of FlexSim, and the first data is the input versus time. The input versus time graph shows the number of flanges produced during that shift, which is from 9 AM to 4 PM. And in the throughput per month, we get to see the same number, which is 843 flanges in the sink, and both of these data is the same. And after that, we also managed to get the throughput per hour, where we get to see the number of flanges produced for every hour. And then we also got the state pie, which shows the state of each processor, sink, queues, and also the operators. They illustrate the usage or the utilization and also the processing of each component. And finally, the conclusion is we managed to reach the goal of the project, which is to produce more than 50,000 flanges per month. But then the results obtained in the FlexSim software differ from the calculation, because we had a model limit in the software used where we did not insert the right number of machines, and we had to redesign our plant. And also FlexSim does not consider scrap rate in the manufacturing plant. So yeah, that's all from us. Thank you.